Welcome back. Last time, we dove into the multimodal advancements brought by Spirit LM, how it bridges text and speech to produce expressive, coherent outputs. It was fascinating to see how multimodal systems expand capabilities while balancing challenges like sentiment preservation.
Yeah, I remember that one. Spirit LM's interleaved training was so intriguing. But it also showed how critical internal consistency is, even within a single modality.
Exactly. And that brings us to today's topic, which shifts the focus to something equally foundational: the self-contradictory hallucinations in large language models. While Spirit LM expanded what these models can do, today's discussion zeroes in on whether they can maintain logical coherence within their outputs.
That sounds super relevant. It's like moving from what they can do to how well they do it. What makes this particular paper so important?
Great question. This paper, Self-Contradictory Hallucinations of Large Language Models, Evaluation, Detection, and Mitigation, makes some groundbreaking contributions. First, it highlights self-contradictions as a critical form of hallucination, something surprisingly underexplored.
Oh, so it's not just about catching random mistakes, but contradictions specifically?
Exactly. The authors introduce a novel three-step framework: triggering contradictions, detecting them with logical reasoning, and mitigating them iteratively. And get this, they manage all of this without relying on model internals or external data, which is a huge win for black box models like ChatGPT.
That's impressive. Do they evaluate how well this works in the wild?
They do. The framework achieves around 80% detection accuracy and significantly reduces contradictions while keeping the text fluent and informative. Plus, they've made their tools public, which could be a game changer for both research and real-world applications.
So, this paper really takes a critical step toward making these systems more reliable and trustworthy.
Absolutely. And as we dig into the paper, we'll see how they balance detection, mitigation, and practical implementation. We'll explore key findings, their real-world impact, and even where the framework could grow from here.
Sounds like we're in for an exciting discussion. Where do we start?
Let's kick things off by unpacking how the authors define and motivate self-contradictions. It's the perfect entry point to understanding why this work is so crucial. Ready?
Let's go.
All right, we're diving into the ABSTRACT section of the paper, which gives a bird's-eye view of the research. The study examines a critical issue with large language models, LLMs, their tendency to produce hallucinations, specifically self-contradictions. Let's break it down. The authors explore evaluation, detection, and mitigation of these contradictions, with a key focus on open-domain text generation and question answering. It seems they've also proposed a framework using prompting techniques to handle these issues. So, any initial thoughts or points you'd like us to dig into?
Yes, I'm curious about what self-contradictions exactly are. Could you explain that?
Great question. Self-contradictions occur when a language model generates two sentences within the same context that logically conflict with each other. For example, imagine it says, "The sky is blue," and in the next sentence claims, "The sky is red." The authors point out that identifying these contradictions is important because at least one of those conflicting statements has to be incorrect.
That makes sense. How does this research address those contradictions?
The study outlines a framework that has three main parts. First, it triggers self-contradictions by creating specific conditions for the LLM to generate conflicting statements. Next, it detects contradictions with high accuracy using a prompting-based method. Finally, it mitigates these contradictions through iterative refinement, ensuring the text remains fluent and informative. Pretty neat, huh?
Definitely. Do they rely on external knowledge for any of this?
Actually, no. The framework is designed to work without retrieving external knowledge, which is one of its strengths. Instead, it relies on the logical reasoning capabilities of LLMs to detect and resolve contradictions. This is helpful because many self-contradictions aren't easily verified with online sources anyway.
That's impressive. Did they evaluate their method on real-world examples?
Absolutely. They tested their approach on several instruction-tuned LLMs like ChatGPT and GPT-4, among others. They found that self-contradictions are prevalent, up to 17.7% of sentences from ChatGPT in open-domain text generation. Their detection method achieved around 80% accuracy, and the mitigation approach reduced contradictions significantly while maintaining text quality. So the abstract wraps up by emphasizing that this framework is a practical tool for improving the trustworthiness of LLMs, and it's even accessible to the public. Quite the impactful contribution. So we've just seen how the authors framed their work in the ABSTRACT, laying out the motivation and key contributions. Let's take a step further into the introduction to see how they set the stage and provide more depth to their approach. The introduction begins by explaining how large language models, LLMs, are trained on massive datasets and fine-tuned to follow instructions. This makes them highly capable for a range of tasks like question answering and creative writing. However, the paper points out a major issue. These models often generate nonsensical or unfaithful information, commonly referred to as hallucinations. Self-contradictions are a specific type of hallucination that this study focuses on.
That sounds intriguing. Could you clarify what makes self-contradictions different from other hallucinations?
Sure. While hallucinations generally involve generating untruthful content, self-contradictions stand out because they are inherently logical inconsistencies within the model's output. For instance, if the same model claims a person was born in 2 different years, it's clear something is off. The beauty of this approach is that these contradictions act as a marker for broader issues of factuality in the model's output.
I see. And why do the authors emphasize self-contradictions so much?
Good question. The authors argue that addressing self-contradictions is both practical and necessary. Since 2 contradictory statements cannot both be true, identifying and resolving these is a logical starting point for improving model reliability. Plus, this process doesn't require external validation, which is often complex or impractical in real-world applications.
That makes sense. How do they tie this problem to real-world applications?
They highlight that LLMs are becoming integral in tasks like online search and professional environments, where accuracy is critical. Imagine relying on an AI assistant that contradicts itself. Trust is eroded instantly. By tackling self-contradictions, the framework directly enhances the reliability of such applications.
What's their main insight or key argument in this section?
Their central insight is that self-contradictions provide a unique opportunity. Since these contradictions expose non-factuality directly, the authors propose leveraging them to detect and mitigate inaccuracies in LLM outputs systematically. It's a logical, structured way to improve the model without needing to access its internal workings or external databases. The introduction does a great job of framing the problem and making a case for why this work is important and timely. Let's keep exploring to see how they build on these ideas. All right, with the introduction giving us a clear sense of the problem and motivation, it naturally sets the stage to look at how this work connects to and builds upon previous research. Let's dive into the related work section. In the related work section, the authors explore the broader context of their study by discussing advancements in large language models, LLMs, and the challenges of hallucinations. They cover 2 major themes: the evolution of LLM training methods and the persistent issue of generating unfaithful content.
Let's start with the evolution of LLMs. What do they highlight there?
The paper notes that modern LLMs, such as ChatGPT and GPT-4, achieve impressive capabilities thanks to their training on massive text corpora, followed by fine-tuning to align with human instructions. These models excel at tasks like reasoning and text generation, but their proprietary nature often makes it hard to evaluate their outputs fully.
Oh, so that's the black box issue. How does it relate to hallucinations?
Exactly. Hallucinations, or the generation of nonsensical content, are a significant side effect of this black box nature. The paper cites prior studies emphasizing how these hallucinations undermine trust in applications ranging from professional use to everyday tasks like online searches.
Got it. And how does their focus on self-contradictions fit into this context?
Good point. Unlike general hallucinations, self-contradictions are a subset where the inconsistencies are logical and internal. The authors argue that detecting these requires no external information-only reasoning, which modern LLMs are already good at. This positions their work as a practical and complementary approach to other methods.
Speaking of other methods, do they discuss existing solutions to hallucinations?
They do. The paper mentions retrieval-based methods, where models use external databases or online text to verify content. While useful, these methods are limited by the availability of reliable information. For example, 35.2% of ChatGPT's self-contradictions in their study couldn't be verified online. This highlights why approaches like theirs, which focus on internal reasoning, are so valuable.
That's interesting. Do they compare their framework to similar studies?
Yes, they point to related research that uses logical reasoning for tasks like contradiction detection or factual verification. However, what sets their work apart is its emphasis on refining outputs iteratively to mitigate contradictions while preserving text fluency and informativeness. This focus on post-processing outputs is relatively novel, so the related work section does a solid job of situating their study within the existing landscape and making a case for its unique contribution. It's clear they're filling a significant gap. All right, now that we've explored how this work connects to existing research, let's turn our attention to the heart of the problem: understanding and contextualizing self-contradictions. The next section dives deeper into defining and motivating this specific issue. In this section, the authors set out to clearly define what self-contradictions are and why they matter. Essentially, they frame these contradictions as a subtype of hallucinations that are particularly important because they directly expose inaccuracies in a model's output.
That makes sense. How exactly do they define self-contradictions here?
Good question. A self-contradiction occurs when a language model generates two sentences that are logically inconsistent within the same context. For instance, if the model says, "The Eiffel Tower is in Paris," and then "The Eiffel Tower is in London," those statements can't both be true. The key is that both sentences come from the same model and are tied to the same context.
So, it's not just about factual errors, but logical ones. Why is that distinction important?
Exactly. The authors argue that self-contradictions inherently indicate non-factuality because logical inconsistencies are impossible to reconcile. This makes them a particularly useful lens for detecting broader issues in model outputs without needing external validation.
I see. And why focus on this specific kind of hallucination? Isn't it a narrow scope?
That's a fair point. But the authors make a compelling case. They argue that focusing on self-contradictions provides a clear and manageable starting point for improving reliability. Unlike general hallucinations, these contradictions can be tackled using internal logical reasoning, which modern LLMs excel at. Plus, resolving contradictions directly reduces the non-factuality in the output.
Interesting. Do they provide any data or examples to back this up?
They do. For example, they note that 63.1% of ChatGPT's self-contradictions involve both sentences being non-factual. This highlights how addressing contradictions isn't just about improving logic, but also factual accuracy overall. They also include concrete examples of contradictory outputs and how their framework resolves them.
What about comparisons to other methods? Is there any overlap here?
Yes, the authors contrast their approach with retrieval-based methods, which depend on external data to verify facts. They point out that a significant portion of self-contradictions, like 35.2% in ChatGPT, can't be verified using online text. This underscores the value of their logical reasoning approach as a complement to existing methods. Overall, this section does a great job of defining self-contradictions and explaining their importance. It sets a solid foundation for the more technical parts that follow. Now that we have a solid understanding of what self-contradictions are and why they're significant, it's time to look at the practical side of things, how the authors tackle the issue step by step. Let's delve into their framework for triggering, detecting, and mitigating self-contradictions. This section lays out a three-step process for systematically addressing self-contradictions in text generated by language models. The steps are designed to first expose contradictions, then identify them, and finally resolve them in a way that maintains text quality.
Interesting. Let's start with the triggering part. How do they expose contradictions in the first place?
Great place to start. To trigger self-contradictions, the authors use specific constraints in their prompts to generate sentence pairs about the same context. For instance, they might ask the model to provide two different statements about a given subject, making it likely to produce contradictory information. They carefully structure these prompts to balance freedom and focus, ensuring the model generates varied yet comparable outputs.
That sounds clever. How do they ensure the model actually generates contradictions rather than unrelated sentences?
Good point. They include contextual details, such as a shared subject or entity, in the prompts. For example, they might provide a description of a person and then ask for two different statements about their birth year. This forces the model to stay within the same topic while potentially introducing inconsistencies.
All right, so once they have these sentence pairs, how do they detect contradictions?
For detection, they rely on a logical reasoning step using another language model. They craft prompts that explicitly ask whether two statements are contradictory and provide a chain of thought reasoning process. This step not only identifies contradictions but also explains them, which improves interpretability.
That's a nice touch. Is this detection method reliable in practice?
It is. They report high accuracy rates, with detection achieving around 80% F1 score in their experiments. The use of logical reasoning aligns well with modern LLM capabilities, making the process both effective and computationally efficient.
And what about mitigation? How do they fix the contradictions they detect?
Good question. For mitigation, they use an iterative refinement process. Once a contradiction is detected, the framework edits the sentences to remove the conflicting information while preserving as much non-conflicting content as possible. This step ensures the revised text remains fluent and informative.
Does this approach work across different kinds of text or tasks?
Absolutely. The framework is versatile enough to handle open-domain text generation and shorter tasks like question answering. In both cases, the iterative approach effectively reduces contradictions while maintaining overall text quality. Their evaluation shows up to 89.5% of contradictions can be mitigated with minimal loss of informativeness or fluency. This section showcases a robust and practical pipeline, tying together logical reasoning and text editing to address a critical problem in LLMs. It's a thoughtful and systematic approach. With the framework for handling self-contradictions laid out, the natural next step is to see how this methodology is applied in practice. Let's move into the instances of how the authors implement their approach in text generation tasks. In this section, the authors describe how their framework can be applied to open-domain text generation. They focus on tasks where LLMs generate detailed, multifaceted descriptions for a given prompt, a common scenario for these models.
Open domain text generation? Could you explain what that involves?
Sure, open-domain text generation refers to tasks where the model produces longer, free-form responses based on a user prompt. For example, generating an encyclopedic-style description of a topic. These tasks are challenging because they require the model to synthesize and present its internal knowledge coherently across multiple sentences.
Got it. So, how do they implement their framework here?
First, they generate initial text from the model by providing a general prompt like, "Tell me about the Eiffel Tower." The model then produces a sequence of sentences, which are analyzed for contradictions using the earlier framework.
And how do they incorporate context into the analysis?
Great question. They use a structured approach to define context. Each sentence is analyzed in relation to its preceding text and any relevant entity mentioned. For example, if the topic is the Eiffel Tower, they might frame the context with details like its location or year of construction to keep the analysis focused.
That sounds effective. How do they trigger contradictions specifically for this kind of task?
To trigger contradictions, they structure prompts to elicit alternative statements about the same subject. For instance, they might ask the model to provide two different facts about the Eiffel Tower's height or history. This creates opportunities for logical inconsistencies to emerge naturally in the generated text.
And how do they revise these contradictions in text generation tasks?
Once contradictions are identified, the revision process uses the same iterative refinement method we discussed earlier. The model is guided to resolve inconsistencies while preserving key information and ensuring the output remains fluent. They even include instructions like maintaining coherence with previous sentences.
Do they provide any results or metrics to show this works well for text generation?
They do. Their experiments show that the framework significantly reduces contradictions while retaining over 95% of the original information. Fluency is maintained too, with only a slight increase in perplexity, which measures text complexity. This demonstrates that their approach balances accuracy and readability effectively. By grounding their framework in real-world tasks like open-domain text generation, the authors make a strong case for its practicality and impact. It's a thoughtful demonstration of how theory meets application. Having seen how the framework operates in text generation tasks, the next logical step is to evaluate its performance in real-world scenarios. Let's dive into the experimental evaluation to see how well the approach holds up under scrutiny. In this section, the authors present a comprehensive analysis of their framework by testing it across multiple models and tasks. They aim to measure its effectiveness in triggering, detecting, and mitigating self-contradictions while maintaining text quality.
That sounds thorough. Which models do they test this framework on?
Good question. They evaluate 4 major instruction-tuned LLMs: GPT-4, ChatGPT, Llama 2 to 70B Chat, and Vicuna 13B. These models represent a mix of proprietary and open-source systems, ensuring the evaluation is broad and relevant.
Interesting. Do they focus on specific types of text or tasks for the evaluation?
Yes, they primarily focus on open-domain text generation, where models generate detailed descriptions for topics. They also test the framework on question-answering tasks to see how it performs in shorter, more focused contexts.
What metrics do they use to measure the framework's success?
They use several key metrics. For triggering, they look at how often the framework successfully induces self-contradictions. For detection, they evaluate precision, recall, and F1 score to measure how accurately contradictions are identified. For mitigation, they measure the percentage of contradictions removed, the retention of informative content, and the fluency of the revised text using perplexity.
What do the results show? Is the framework effective across these metrics?
Absolutely. The results are promising. For detection, the framework achieves an F1 score of about 80%, indicating reliable performance. When it comes to mitigation, they report a reduction in self-contradictions by up to 89.5%, while retaining nearly all informative content and maintaining text fluency.
That's impressive. Do they provide any insights into differences between the models?
Yes, they observe variations in the prevalence of self-contradictions and the framework's effectiveness. For instance, GPT-4 produces fewer contradictions overall, likely due to its advanced capabilities, while open-source models like Vicuna 13B show higher rates of basic factual errors. However, the framework works consistently well across all models.
Do they discuss any limitations or edge cases in the evaluation?
Good point. They acknowledge that some contradictions are harder to detect or mitigate, especially when subtle nuances are involved. Additionally, while the framework excels in logical reasoning, it may struggle with extremely complex or ambiguous contradictions. They highlight these as areas for future improvement. Overall, the experimental evaluation solidifies the practicality and impact of their framework. The metrics and comparisons paint a clear picture of its effectiveness, making this a compelling piece of the research. With the evaluation providing a solid understanding of the framework's strengths and areas for improvement, the authors bring everything together in the conclusion and discussion. Let's see how they wrap up their findings and reflect on the broader implications. In this part, the authors emphasize the significance of their work in addressing self-contradictions, a pervasive issue in language models. They reiterate how their framework effectively identifies and mitigates these contradictions, while maintaining the fluency and informativeness of generated text.
That's a strong conclusion. Do they highlight any key takeaways or broader impacts?
Yes, they frame their framework as a practical solution to improve trust in LLMs. By relying on internal logical reasoning rather than external data, the approach complements existing methods like retrieval-based techniques, filling a critical gap in the field.
Do they mention specific areas where their work could have a significant impact?
Absolutely. They point to high-stakes applications such as professional environments, automated customer support, and academic research, where trust in model outputs is essential. They argue that their framework can serve as a valuable tool for enhancing reliability in these domains.
What about limitations? Do they discuss any challenges or future directions?
Good question. They acknowledge that their framework is currently limited to resolving contradictions between two sentences generated in the same context. But future work could expand this to detect contradictions across different parts of a longer text. They also suggest exploring ways to train models to avoid generating contradictions in the first place.
That makes sense. Do they propose any potential improvements for broader applicability?
They do. For instance, they suggest fine-tuning smaller, open-source models to act as analyzers, or even integrating contradiction mitigation directly into the generation process. These ideas highlight their commitment to making the framework more efficient and scalable. Overall, the conclusion and discussion tie together the contributions and future opportunities well, leaving a clear path for ongoing research in this space. It's a fitting end to a comprehensive study. And that brings us to the end of today's discussion. We covered some fascinating points, like how self-contradictions expose deeper issues in language models, and how this framework not only detects but also mitigates them effectively.
Yeah, the idea of using logical reasoning without relying on external data really stood out to me. It's such a practical and scalable approach, especially for black box models.
Absolutely. And the iterative refinement process they proposed? That's a game changer for maintaining fluency while improving accuracy. Definitely a framework that sets the stage for future innovation.
Totally. Plus, the fact that they made their tools publicly available, it shows a commitment to community impact and collaboration.
Couldn't agree more. Thanks for tuning in today and exploring this important step toward making AI more reliable and trustworthy.
Thanks for listening, everyone. Catch you next time.